Chapter 5, Section 5. Our objective, learn to identify similar figures. Essential question, how do I determine whether figures are similar? Vocabulary we'll need to know, similar, corresponding sides, and corresponding angles. I want you to start by thinking about these three questions. First, what is the difference between similar and same? Usually in our mind, same means exactly the same or identical. Similar means characteristics that are common. For example, two people may be wearing a black t-shirt, but the design on it may be different. What types of things might be similar but not necessarily the same? You could have eye color, hair, shapes, clothing. You could think of candy bars, any type of food, a whole variety. Lastly, can similar things be the same? Well, I'll let you consider that one and think about some different options. Similar things. You may have similar things that have different characteristics. Would it be possible, if you had the exact same item, to call them similar? I'll leave that one for you to think about. Similar figures, in terms of shapes, have the same shape, but not necessarily the same size. So for example, a triangle and a rectangle cannot be considered similar. Corresponding sides of two figures are in the same relative position, and corresponding angles are in the same relative position. Two figures are similar if the lengths of corresponding sides are proportional and the corresponding angles have equal measures. Here's the actual book definition for similar polygons. Make sure you add to your notes the piece on the bottom. To be similar figures, shapes need A, the same angle measures, and B, proportional side lengths. So you can see in these two shapes up above, we have a degree of 53 for one of the angles. In the second triangle, we have also a degree of 53. We have a 37 degree and a 37 degree. We have a 90 and a 90. So they qualify for part A, that the same angle measures are there. The second thing we check is the ratios of the sides. So what we have to make sure is the corresponding sides that go together. So the side of 48 is between the angle of 37 and 90. That's going to match up with 24 because that's between 37 and 90. Sometimes you have to visualize what would happen if you were to rotate these shapes so that they were directly on top of each other, matching their angles. So we could set this up as side BC over side FG, which would be 48 over 24. We could do the same thing with sides EF and AB, so 60 over 30. Now it's important to make sure that if I started with a larger triangle in my ratio on the first one, I have to do that in the same thing on the second one. So the last ratio would be 36 over 18. What these all have in common is they are proportional and they're all equal to 2 over 1. We'll talk more about scale factors in a couple lessons from now, but scale factor of 2 would be what it would take to multiply the smaller one to get the larger one. If we wanted the scale factor from larger to smaller, it would be the reciprocal of that, which is 1/2. So these shapes proved to be similar because they had the same angle measures and they were proportional on their sides. Which rectangles are similar? If you look closely, it may jump out at you. Let's compare J and K. If we compare length of J to length of K, we have 10 over 5. Width of J is 4, width of K is 2. Cross multiply, we get 20 and 20. Let's compare J and L. 10 over 12, 4 over 5, 50 does not equal 48. So the rectangles J and K are the two that were proportional, which means they're the two similar rectangles. Going back for a second, we didn't talk about angle measures because in every rectangle, they're all 90 degrees. A picture 10 inches tall and 14 inches wide is to be scaled to 1.5 inches tall to be displayed on a web page. How wide should the picture on the web page be for the two pictures to be similar? It works well in these cases to draw out a visual. So we have a 10-inch tall picture that's 14 inches wide. Scaling means we're going to keep it the same shape but reduce all the sides. So we have 1.5 inches compared to X. So KWC, what do we know? What are we trying to find out? And then we'll check our answer at the end. Here's what we know. our picture. We are trying to find out what x is, which is the width. Our plan, to me this looks like a proportion because we're looking at them being similar, so let's set up a proportion. We can do this multiple ways. One way would be to compare 10 inches, which is how tall it is, to the width, which is 14 inches, which would mean in the second ratio we would compare 1.5 to x. Next we cross multiply and divide, so 14 times 1.5 divided by 10, and we get an answer of 2.1. Lastly, to check your work, you could cross multiply. 10 times 2.1 is 21. 14 times 1.5 is 21, so that seems to be a proportion, and we've got the right answer. Lastly, a t-shirt design includes an isosceles triangle with side lengths 4.5 inches, 4.5 inches, and 6 inches. Isosceles means two sides are the same. Even if you didn't know that, it wouldn't affect the problem because they give you all the dimensions. So 4.5, 4.5, and 6. An advertisement shows an enlarged version of the triangle with two sides that are each 3 feet long. So because two sides are 3 feet, we know those must be the matching sides. What is the length of the third side? What's nice about proportions is we don't have to do conversions. We have inches and feet. As long as we line things up correctly, we won't need to convert anything. So one way to compare this would be to compare 4.5 inches to the side 3 feet, because those are corresponding sides. We don't have to do a second ratio for that because they're the same. We don't need to include it. Then we would start with 6 inches over x feet. So we have inches over feet, inches over feet. So we're going to cross multiply. 3 times 6, which is 18. And then 18 divided by 4.5 equals 4 feet. Our answer seems reasonable. If we wanted to check and make sure, we could cross multiply 4.5 times 4, and that would give us 18, which matches our other diagonal. It's pretty slick when you can set up cross multiplying for these problems. Make sure your notes are filled out completely. Make sure you have a question for each chunk of information that you wrote down. Review your notes and complete the summary before class.